There it is. The quotient rule. You think the product rule looked long? Take a look at that one. Whew. So again, I'm going to color code it. I'm going to color code when you have one function divided by another function. In function notation or in Leibniz notation, what happens? And this is part of the reason when I learned the product rule, I always kept the second one the same first because it matched up with the quotient rule. With the quotient rule, the order does matter. And you always have to start by keeping the bottom one the same first. So whatever function's on the bottom, that stays the same. Then you multiply by the derivative of the function on the top. Then you subtract, and now the top function stays the same. And you multiply by the derivative of the bottom function, divided by the bottom function squared. And unlike the product rule where you could multiply some things out to make it in a form that we could before, usually the quotient rule doesn't have that. So here we have a function on the top, which I'll highlight again in yellow, and a function on the bottom, which I'll highlight in green. Quotient rule is easy to see which is one's on the top and which one's on the bottom, so that's nice. And again, you can go directly to the answer. So how does the answer say? We keep the bottom the same, multiplied by the derivative of the top. Then we subtract, keep the top the same, multiplied by the derivative of the bottom. And then on the bottom, you take the original thing you had on the bottom and square it. Yes?
Do you have to simplify these ones?
Usually not, although they are a favorite when they have show that questions. So this one might say, could you show that this is equal to this? And that wouldn't be hard because all you'd have to do is multiply out the top because the bottom's already the same. Now again, if you had wanted to, you could have separated your two functions. Here we have our top function and the derivative of our top function, our bottom function and the derivative of our bottom function. If that helps you put things in. But again, usually you can go directly to the answer, just following the formula. So the quotient rule has a lot of things that are similar to the product rule. The quotient rule has keep one the same, derivative of the other, keep the other the same, derivative of the first. And there's a subtraction sign. But the quotient rule, it's important that the one that stays the same is the one on the bottom. Yes?
For the notation,
Mm-hmm.
isn't it dy?
Yeah, we should have dy, dy. Thank you. So I'll give you a head start on the next couple. You can see in 5b we have a show that. Again, for the most part, this is all you'd be expected to do. And you'd be done. One step. If you wanted to simplify it, or if you did simplify it, this is what you would get in the end. If you did some of your work off to the side, wanted to check individual derivatives, there they are. It's nice in the next one that it says you do not need to simplify. So no need to simplify, so one step, there it is. And again, putting these things together isn't that hard. And yet, when someone sees that you went from step one to that step all in one, like it, if you didn't know what was going on, it would look very confusing. But it's not that hard. So then finding the slope of a tangent, find your derivative. Again, you can simplify if you like. Plug in -1, simplify that again, and the slope happens to be 1.
I just make them a joke.